friends, welcome back. Now we are with the next step of hybridization, that one is called as the sp3 dehybridization, because in previous videos we are completed sp3. Now what happens in the sp3 dehybridization, which are the important aspects? Now see toward the board. Now dear students, if we try to define this sp3 hybridization, the hybridization in which mixing of one S, listen very carefully, what happened in this case? In this case, 1s plus 3p plus 1 plus 1d orbital takes place. After mixing, it gives a 5 new orbital which having equivalent in energy as well as shape. Such a 5 new orbital is called as the sp3d orbital. Is it okay? Now before going to discussing the sp3d hybridization, I am giving you some important aspects related to this. Those molecules, suppose for example, see, now the first example of sp3d hybridization, that one is called as the PF5, which is called as the phosphorus pentafluoride. You know very well, in phosphorus pentafluoride, 5 fluorine atom attached to phosphorus without lone pair. It means number of hybrid orbital is 5, therefore hybridization is sp3d. Is it okay? Those molecules which have a sp3d hybridization with 5 sigma bond, the geometry of this molecule is trigonal. Geometry of this molecule is trigonal bipyramidal. The geometry is trigonal bipyramidal. And those molecules which have a geometry trigonal bipyramidal, making a 2 bond angle, one bond angle is the 120 and another bond angle is the 90 degree, 120 and 90. These are the very much interesting concept related to this phenomenon. Now see how to define this sp3d hybridization. Suppose for example, dear student, you know phosphorus, atomic number of phosphorus is 15, yes or no? The electronic configuration is what? 1s2, then finally 2s2, then 2p6, then 3s2, 3p3. Is it okay? Because atomic number is 15, 6 plus 2, 8 plus 10, 3s2, 3p3. This is the electronic configuration of phosphorus in ground state. It means that we write only the valence electronic configuration. In its s orbital contain 2 electron and p orbital contain 3 electron, and you know very well d orbital is completely empty. So finally 3p3, 3d0. Now dear student, you know very well what happened in their excited state. In excited state, the one of the electron from S excited to the empty d orbital, because you know this concept we already discussed in the variable valency. Now in excited state, that electron jump into the empty orbital. Then after jumping of this electron, the same electronic configuration become 3s1, finally 3p3 and then 3d1. This is the electronic configuration of phosphorus in their excited state. Now what happened in their s orbital? In s orbital it contains the 1 electron. In p orbital it contains the 3 electron. That one is called like the 1, 2 and 3. And finally d orbital contains the 1 electron. This is called as the sp3d. Okay. Now here, now in excited state, mixing of 1s, 3p and 1d orbital takes place. After mixing, it gives the 5 new orbital, and such a 5 new orbital is called as, this one is also now sp3d, this one is sp3d, 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 sp3d. Now listen very carefully, what is the shape of this sp3 hybrid orbital? Suppose for example, this is a phosphorus. Now suppose we have a here one fluorine, we have a here one fluorine, we have a here one fluorine. So these fluorine making and shape trigonal, and 2 fluorine are present on this affix side. This is called as here one fluorine, here this is called as the trigonal bipyramidal. In trigonal, bond angle is 120 and for this bond angle is 90. It means that those molecules which have a trigonal bipyramidal shape, then the bond angle is 90 and 120. So this is the very important concept. What happened in trigonal bipyramidal? In trigonal bipyramidal, 1, 2, 3, these 3 bonds are equatorial bond. Bond length of equatorial bond is always less than the bond length of axial bond, and these 2 bonds is the axial bond, because you have one topic, that one is called as in your 12th standard P block element. The concept related to this phenomenon is already present in your P block concept, but before going to discussing, listen very carefully. This is an example of sp3d hybridization. Listen, dear students, write down the important aspects related to this hybridization in your notebook. In this hybridization, 1s, 3p and 1d orbital are mixed to give 5 new orbital which are equivalent in shape and energy, called as sp3d orbitals. Out of this 5 orbital, 3 hybrid orbital are at 120 angle, 1, 2, 3, 3 hybrid orbital are at 120 angle, and 2 hybrid orbitals, these are the 2 hybrid orbitals are perpendicular to the plane of 3. Now these are the perpendicular to these 3 hybrid orbitals, and that is trigonal planar. The shape of the molecule become trigonal bipyramidal. The shape of this molecule become trigonal bipyramidal. In this hybridization, तुम्ही कधी लक्षात ठेवा, the d orbital involved in this hybridization, listen very carefully, this is very important things. The d orbital involved in this hybridization is always dz square orbital. So this is the dz square orbital involved in the mixing of this hybridization. Number of time such type of question may be asked in your examination. Which d orbitals are involved in this hybridization? If anyone asks you the question, then answer is must be the dz square, because in d orbital we have a 5 degenerate orbital, which is that dxy, dyz, dzx, dx square, y square and dz square. The dz square orbital involved in the mixing of sp3 dehybridization. Another next important things, and see, in this way the 5 sp3 hybrid orbital form 5 sigma bond with 5 fluorine atom, 1, 2, 3, 4, 5 fluorine atom to give molecule pf5, and shape of this molecule is trigonal bipyramidal. So as per my idea, you don't have any problem in this case. So this is called as the sp3d hybridization. Now dear student, now I am going to discussing with you the next and very interesting concept. That one is called as the example of sp3d hybridization, because example of sp3d hybridization is also important. And example of this hybridization we are discussing with the perfect case. Now see the first case. That first case is called as 5 sigma bond with a 0 lone pair. You know very well which is the first case. The first case is 5 sigma bond. Listen very carefully. 5 sigma bonds with what? 5 sigma bond with 0 lone pair. Now dear student, which are the very important concept related to this phenomenon? What happened in this case? 5 sigma bonds with 0 lone pair. This is the first time very important case present in front of you. Now I am given to you so many example in that 5 sigma bond with a 0 lone pair is there. Suppose for example we consider here example, listen very carefully. After the example, next concept, number of sigma bond, after that number of sigma bond, number of lone pair of electron. Finally after lone pair of electron, the next concept is there, that one is called as the hybridization. After the hybridization, finally we consider this is bond angle, as all you know very well what is the bond angle of this is, and once if you know the bond angle, then finally the shape of this molecule. So these are the very interesting concept related to this phenomenon. Now dear student, the first and very important example, PF5, PCl, phosphorus, phosphorus, arsenic, antimony, bismuth. Now see, these are the element of this nitrogen family: phosphorus, arsenic, antimony, bismuth. You know very well. Nitrogen we cannot consider because nitrogen doesn't have a d orbital. That's why that nitrogen does not involve in the sp3d hybridization, even though nitrogen from the same family. But nitrogen never gives sp3d hybridization because nitrogen doesn't have d orbital. Okay. Now the first example of this is, suppose for example PF5, then PCl5, then after that PCl5, see the next example AsF5, because is from the same family, AsF5. Then after AsF5, then see AsCl5, see here AsCl5, then SbF5, because all these elements from the same family, SbF5. Then after SbF5, suppose for example we consider here SbCl5, then here SbCl5, after that BiF5, then BiCl5, BiF5, BiCl5, and etc. And finally, so these are the cases in which, suppose for example you consider, these are the cases in which only 5 sigma bond is present. In this all molecules 5 sigma bond is present with 0 lone pair. Obviously if 5 sigma bond with 0 lone pair, it means there is no lone pair repulsion, no lone pair bond pair repulsion. So obviously If repulsion is absent, then at that time this hybridization show regular geometry as well as normal bond angle. Then what happen here, due to zero lone pair, no doubt hybridization is of this molecule is sp3d. If hybridization is sp3d, making and bond angle 120 degree and 90 degree, you know 120 and 90 because the geometry of this molecule is you know very well, the geometry is trigonal, what? Trigonal bipyramidal. So this is the very interesting phenomenon, and those molecule which have a geometry trigonal bipyramidal, it have a 2 bond angle 120 and 90 because if 3 bonds are trigonal, 2 bonds are bipyramidal, that is axial and equatorial bond. The 3 equatorial bond making and bond angle 120 and 2 axial bond making and bond angle how much? 90. So this is the very interesting concept related to this phenomenon in which 5 sigma bonds with 0 lone pair. So dear student, as per my idea, you don't have any problem in first case. Now we are going to the second case. Write down all these things in your notebook. So which is the second case? In second case now we are considered here 4 sigma bond. In second case we are considered which point we are considered here? In place of 5 sigma bond, in second case 4 sigma bond with a 0 lone pair, in place of 0 lone pair with 1 lone pair. So which are the example of 4 sigma bond with 1 lone pair? Listen very carefully. I will give you next sulfur, selenium, tellurium and so on. These are the element of oxygen family, but we cannot consider oxygen due to non-availability of d orbital. Now what happened in this case, sulfur, suppose dear student I am given to you SF4. You know valence shell of sulfur contains 6 electrons, but only 4 electrons are participant to form the 4 covalent bond with 4 fluorine atom. That's way 2 electrons are remain, and that electron is called as the lone pair of electron. The first example is SF4. Second example is SeF4, because both are the from same family, either SF4, SeF4 or a TeF4, or what we people say TeF4 or a PoF4, that is called like the sulfur, selenium, tellurium, polonium and so on. PoF4, dear student, PoF4. Finally the next one is called as the PF4 minus. Suppose for example I have a PF4 minus. Listen very carefully. How the PF4 minus is formed I will explain you, because this minus now we are considered in hybridization. This is very interesting. Listen, why I am explaining this concept, repeat, because most of the student get confused here, because valency of phosphorus is 5 na, highest valency is 5, but with a 4 1 negative is there, it means something happens. What things are happen? See toward this, you know, suppose dear student this is phosphorus, atomic number is 15. Listen how the PF4 minus is formed, how this minus we count in the hybridization. Atomic number of phosphorus is 15. Electronic configuration is, you know, 1s2, 2s2, 2p6, then finally 3s2, 3p3. This is the electronic configuration of this phosphorus. Now in ground state what happened here? This is a 3s2 and this is a 3p3, dear student, 1 2 3, and in ground state 3d is empty. So mixing of 1s, 2p and 1d orbital takes place. See now what happened in this mixing, listen very carefully. In this mixing we got a such 5 orbital. Listen very carefully. Suppose 1 2 3 4 and 5. So what happened in this 5 orbital after mixing? Out of this 5 orbital, 2 orbital have a 1 lone pair of electron, 3 orbital contain the unpaired electron, and 4th d orbital is 100% empty orbital. So these are the very interesting concept related with this hybridization phenomenon, which is called as the sp3d hybridization. So what happened in the sp3d hybridization? This is an example of 4 sigma bond with 1 lone pair. Now dear student, what happened? Now these are the one orbital which contain the lone pair of electron, that is, and this is 1 2 3. Okay, this is 1 2 3, and another. Now these 3 hybrid orbital contain the unpaired electron, that forms a covalent bond with 3 fluorine atom, because 1 fluorine donate electron, another fluorine, next fluorine. But 4th orbital is completely vacant, and the fluorine come toward the 4th orbital by donating both electron, and due to this both electron the negative charge is present. Actually PF4 minus is a case in which the central atom contains the 4 sigma bond 1 2 3 4, but the 4th sigma bond is formed by the 4th fluorine atom by donating its pair of electron, and such bond is called as the coordinate bond. Which bond? Coordinate bond. That's why the negative charge is present. Therefore in PF4 minus, So PF4 minus is the case in which central atom have a 4 sigma bond with a 4 after PF4 minus. Same things happens here. AsF4 minus, obviously phosphorus, arsenic, antimony, bismuth, these are the from same family. After AsF4 minus, the S example is there SbF4 minus, because antimony is from the same family, SbF4 minus. Then SCl4, SeCl4, the next example SCl4. SCl4 means in place of SF4 this is SCl4. After that SeCl4 in place of fluorine, here chlorine is there, same molecule, only halogen is same, SeCl4. Then TeCl4, then that one is called as the Te what after this TeCl4. Okay, obviously in place of fluorine here chlorine is there, that one is TeCl4. Now dear student, these all are the molecule in which how many sigma bond is present? 4 sigma bond with 1 lone pair. Now keep in your mind, might maybe happen out of this example, maybe they ask you in examination question one of the example out of this. So listen very carefully, write down all these things in your notebook, because I am going to discussing with you very detailed hybridization concept, because hybridization is a very interesting and key point of the nature of chemical bonding topic or chemical bonding topic. Not only chemical bonding but every organic chemistry you must know hybridization phenomenon. So these are the molecule which contain the 4 sigma bond with 1 lone pair. No doubt hybridization is sp3d, no doubt hybridization is sp3d, hybridization is sp3d. But listen very carefully, bond angle is less than 180, keep in your mind, bond angle is less than 180, less than 90 and less than 120. Keep in your mind those molecule in which central atom have a 4 sigma bond with 1 lone pair. No doubt hybridization is sp3d, but bond angle is less than 180, less than 90, less than 120. These are the bond angle. And finally the geometry of shape of this molecule is irregular tetrahedron. Keep in your mind, the shape of this molecule is irregular tetrahedron. The shape of this molecule is irregular tetrahedron. So this is the very interesting concept. All these are the molecule which have 4 sigma bond with 1 lone pair. Therefore hybridization is sp3d, and making and bond angle less than 180, less than 90, less than 120, and geometrical shape of the molecule is irregular tetrahedron. So dear student, these are the concept now which I discussed with you by considering the sp3d hybridization. You know, in sp3d hybridization, this is the second case in which 4 sigma bond with 1 lone pair. First case 5 sigma bond with 0 lone pair. Now we are moving toward the next case, that one is called as 3 sigma bond 2 lone pair. Now listen, these case also very important. 3 sigma bond with a 2 lone pair. Then what's happened with the bond angle, what's happened with the geometry? Now this is the third case which I am discussing with in front of you. This is called as 3 sigma bond with how many lone pair? 2 lone pair. Now dear student, dear friends, listen, which are the example of this molecule? Now example of this molecule is ClF3. You know very well, in valence shell of chlorine contains 7 electron. If valence shell contains 7 electron, only 3 fluorine atom forms a bonds. Out of 7, 3 electron, 7 minus 3, that become the 7 minus 3 is equal to 4. 4 electron means 2 lone pair. This is 1, 2, 3, 4 means 2 lone pair in ClF3. Then like the ClF3, same BrF3, because fluorine, chlorine, bromine, iodine is from the same family. But we cannot consider fluorine in this hybridization due to unavailability of d orbital. But we start from the chlorine ClF3, then finally BrF3, then finally IF3. After BrF3, then this is IF3, and then finally ICl3. These are the molecule in which central atom have a 3 sigma bond with a 2 lone pair. 3 sigma bond with 2 lone pair. With the 3 sigma bond 2 lone pair, some another example is there. That one is okay. These are the example with 3 sigma bond 2 lone pair. Making and hybridization what? No doubt making and hybridization sp3d. If 3 sigma bond 2 lone pair is there, no doubt lone pair bond pair repulsion is very strong. Lone pair bond pair repulsion is very strong repulsion. So due to this strong repulsion, the bond angle of this become 87 degree, 87.6 degree. The bond angle become 87.6 degree, and the shape of this molecule is a T shape. T shape. Keep in your mind, the shape of this molecule is T shape. Whenever we consider this phenomenon by considering the shape of this molecule, so listen very carefully, the shape of this molecule become the T shape, in which all the cases we have to be considered here, dear student. Now this is the next case which we are considered 3 sigma bond with a 2 lone pair, then the shape of this molecule become the T shape. Now the next and very interesting example we are considering here, that one is called as 2 sigma bond with 3 lone pair. Now the last and final case we are considered here, 2 sigma bond with a 3 lone pair, 2 sigma bond with a 3 lone pair. So how many example is possible in this case? 2 sigma bonds with a 3 lone pair. See dear student, this is now fourth case I am representing in front of you. Fourth case, which is that fourth case? Only 2 sigma bond with a 3 lone pair. Very interesting case. Lone pair of electron exceed the sigma bond. देखो अब यहाँ पे मतलब लोन पेयर ऑफ इलेक्ट्रॉन सिग्मा बॉन्ड से भी ज्यादा है. वेरी इंटरेस्टिंग एग्जांपल, 3 सिग्मा बॉन्ड्स विद 2 लोन पेयर. Now the best example of this is I3 minus. The best example is I3 minus. After that I3 minus, suppose Br3 minus. Okay, I3 minus Br3 minus. Obviously no need to say I3 minus Br3 minus. Then ICl3 minus. This is also very I'm sorry, ICl3 no, ICl2 minus. After that IBr2 minus, then finally ClF2 minus, then ClF2 minus, and this is XeF2, xenon difluoride. So all these are the example in which a central atom have only 2 sigma bond with a 3 lone pair. Suppose I am given to you XeF2. Dear student, this is Xe, this is one F, this is another F. But outer shell of xenon contain 8 electron, because xenon is a noble gas. Octet of the xenon is complete. If it contains the 8 electron, it forms only 2 sigma bond with the 2 fluorine. That means 8 minus 2, 6 electron is remain. 6 electron means 3 lone pair. 1, 2, 1, 2, 1, 2. 3 lone pairs are present on that xenon. Therefore, XeF2 is an example of 2 sigma bond with a 3 lone pair. Dear students, then hybridization of this molecule is sp3d. Now the bond angle is 180. Exactly, bond angle is 180 because geometrical shape become the linear. If you know this concept, it means your chemical bonding is 100% perfect. You don't have any problem in the chemical bonding. Listen, I am given to you so many example in front of you. You read very carefully all these example, because these are the very detailed concept required to you. You solve any book, you easily solve that book if you know all these examples. So I3 minus, Br3 minus, ICl2 minus, IBr2 minus, ClF2 minus, XeF2 and so on. These are the example of the sp3d hybridization. But 2 sigma bond with a 3 lone pair. Whenever 3 lone pair are present on that particular central atom, then at that time the lone pair repulsion is very strong. And whenever lone pair repulsion is very strong, then at that time geometry of that molecule is completely distorted, that never become the trigonal bipyramidal. So in place of trigonal bipyramidal, that become the linear if it have a 2 sigma bond with a 3 lone pair. So my dear student, till now we are completed maximum part of this hybridization. Now I am going to discussing with you the next and very interesting last but one hybridization, which is called as the sp3d3 hybridization. So what happened in this sp3d3 hybridization? Now which are the important aspects related to this phenomenon? You must be very serious with this. Now what is the meaning of sp3d2? Mixing of 1s 3p, and in place of 1d here a 2d orbital is there. And which d orbital? Either it may be dz square and dx square and y square. These 2 orbitals are involved in this mixing. dxy, dyz, dzx, these 3 never involved in this mixing, because when we go toward the higher level study of the d orbital, now initially d orbital are degenerate. When that d orbitals are involved in the bond formation, then degeneration of that d orbital is lost, and after losing the degeneracy, d orbital are split into 2 sets. That one is called the T2z and EZ. T2G means the triply degenerate, that one is the dxy, dyz, dzx, and doubly degenerate, that is dz square, dx square, y square. In those hybridization we require only one d orbital, then that d is dz square. If we require 2d orbital, then that 2 orbital are dz square and dx square, dy square, because these two are degenerate. And if we require the 3d orbital, then that 3d are dxy, dyz, dzx, and so on. So this is a very interesting concept required to you by considering sp3d. Now dear student, what is the definition of sp3d2 hybridization? In this hybridization, mixing of 1s, 3p and 2d orbitals of the same atom. After mixing, it gives 6 new sp3d2 orbitals, 6 new sp3d2 hybrid orbital having equivalent in shape and energy, and this is called as sp3d2. Write down in this. Now I will give you one example to you. The best example of sp3d2 hybridization is SF6. Now dear student, atomic number of sulfur is 16. The electronic configuration 1s2, 2s2, 2p6, 3s2, 3p4. This is the electronic configuration of sulfur in their ground state. You know, in ground state s orbital contain 2 electron and p orbital contain 1, 2, 3, 4 electron, and finally my dear student, d orbital is 100% empty. But what happened in this excitation? This electron excited in empty state in the first excited state. In first excited state, this become the 2 electron, this become the how many electron? This become the 1, 2, 3 electron, and finally 1 electron entered in d orbital. But in second excited state, one more electron of s entered in the empty d, and finally in second excited state, all these electrons become the unpaired, and after becoming this unpaired electron in d orbital, 2 unpaired, mixing of 1s, 3p and 2d orbital takes place, and after mixing it gives a 6 new orbital, and this in this 6 new orbital, this is also sp3d2, 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 and those which have a sp3d2 habit orbital, then the geometrical shape of that molecule is octahedral. What is the geometrical shape of that molecule? Listen very carefully. This is the very interesting and important concept. Therefore, SF6 is formed by sp3d2 hybridization, and the geometry of this molecule is a octahedral. Listen very carefully. Octahedral. This is perfect and crystal clear phenomenon. Geometry is octahedral, and whenever the geometry is octahedral, then 100% bond angle is 90. Listen. Hybridization sp3d2, hybridization what? Hybridization sp3d2, geometry octahedral, bond angle is the 90. Now I am given to you some example of this hybridization is SF6, dear students, comma AlF6 minus, because valency of aluminum is 3, extra 3 fluorine atom is there, therefore obviously 3 fluorine atom act as a ligand, they are come toward the aluminum by donating its pair of electron, therefore this is AlF6 minus AlF6, finally PF6 minus, only 1 minus because higher valency of phosphorus is 5, one more extra halogen is there. After that ICl minus, ICl5 minus, then XeF4, then XeOF4, this is very interesting concept, and finally ICl4 minus. Dear student, these are the very interesting phenomenon related to you, which is called as the sp3d2 hybridization, and these are the example of sp3d2 hybridization. Then last hybridization we will discussing in the next video. Thank you very much.